Okay, pay very close attention to where you are, all right? Both of them look exactly the same, or both sides of this paper, but it's 4.1 practice B. I started with practice B because when we showed it to the students, they said this was a harder one. So I want to make sure we do the harder ones, and then I'll let you do some of the easier ones by yourself, right? So first things is take some notes. This is the standard form of an equation. When I have this form, I factor by using our x method. Remember that our x method puts b here, a times c here, divide by a, divide by a, and these, the factors have to equal b, right? We're gonna use that over and over again, right? So I wanna make sure that that's what we have. But then also write down this. Oh, x-intercepts equals solutions equal roots equals zeros. You've seen this before, right? You've seen that before, but I'm gonna kind of explain it when we do some of these examples. I'll do a couple really slow and then I'll do a little bit faster, right? Let's start out with this one right here. If you look, that's a 1. When there's not a number in front of x, that's a 1. When there is no x, so this gives us our ideas here. This is a. Now there isn't a term that has x, so that means b equals 0, and then this is c. So when I see that, I write it out. There's my x method. I put b here. I put a times c, which is -1. Divide by 1, divide by 1, right? Just plugging in for this. And the factors of this have to equal 0. Right? What does that mean? If they equal 0, that means it's the same number, one positive, one negative. Which when I look at this, that kind of gives it away, 1 and -1. 1 times -1 gives me -1. 1 plus -1 gives me 0. So we put those in. That equals 1, that equals -1. And so then those come back down with the x. X plus 1 and x minus 1 equals 0. That is this equation factored, so it still equals 0. Now, just take this for example. If I told you that a times b equals 0, what do I know about a or b? One of those two numbers has to be 0. Okay? So if I say this times this equals 0, one of these has to be 0. So think about it. How can I make this equal 0? That would be if x equaled -1, -1 plus 1 is 0. How could I make this equal 0? If x equals +1, that would make this 0. So my answers are x equals 1 or x equals -1. That is the solutions. When they say solve this, that is a solution. Now, they actually said to solve it by graphing. If I graph this, that's -1, that's 1 right there. This is what the graph would look like. It would go right through those points at 1 and -1. This is x-intercepts. So here's my -1 and 1 for solutions, -1 and 1 x-intercepts. And then why are they called zeros? Well, if I was gonna graph this, I would graph this as y equals that, right? Or y equals this, whichever. And that tells us when does y equal 0. That's why they're called zeros, because it's right here. This is 1, 0. The y is a 0. This is -1, comma 0. The point itself, right, if I'm graphing it. So that's why it's called zeros. So that's why the names come, but it depends on what they ask us. We can always just graph it and look for these points, and then that's the answers. That's the solutions. If you want to do these on the calculator, you could do them just by graphing it. Now, when I look at this, it's not equal to 0. So if it's not equal to 0, I can't graph it yet. Here's what I have to do, just basic algebra. Minus 4x minus 2. Do the same thing on this side. So now the equals comes down. That's 0, that's 0. So it all equals 0. And since these have different variables, they don't go together. They just all stay separate. 6x squared minus 4x minus 2. So now there's A, there's B, there's C. Okay? If you're using a calculator, graph this. Find where it crosses the x-axis and you're done. This right here is the hardest problem on here because it's got A not equal to 1. It's got an A that's equal 6. So that's 6 times C, which is negative 2. Here's B, negative 4. Divide by 6, divide by 6. All right, so this brings us all the way back around to all the stuff we did before. All right, hopefully this is a good review. 6 times negative 2 is negative 12. We're looking for factors of that equal negative 4. So 1 times 12, that's not going to equal negative 4. 2 times 6, that could equal negative 4. And then it's 3 times 4. We know that's not going to add up to that. Now, if I want a negative answer, one of these has to be negative because when I multiply, I want negative 12. If I want a negative answer, I make the bigger number negative. So 2 and negative 6. So here's 2, here's negative 6. If I divide them, that's just negative 1. This reduces to 1 over 3. And we got x plus 1 over 3 and x minus 1. But remember, if we get a fraction, we have to do the bottoms up. So we got to take the 3 and take it in front of the x. That's what we called it before. So this equals 3x plus 1 times x minus 1. And that still equals 0, right? We're still setting it up, going from here, it always equals 0. Okay, what makes this equal 0? If I put a 1 in here. So x could equal 1, or x could equal, this one I'm not able to just look at, but I can solve it. All I have to do is, when would this be 0? Well, solve it. 3x plus 1 equals 0. Minus 1 minus 1. That goes away. Got 3x equals negative 1. Divide by 3. Divide by 3. That cancels. So x equals negative 1/3. So there's my solutions. Again, if I graphed it, I can find it, but you're going to need a calculator and be able to find those exact points.